Hi, let's evaluate this summation. Summation n belongs to n, sine of n by 2 power n. Yes, let me make it as I. Let's see how to solve it. So, I equal to summation n belongs to n. This sine n, we know that formula e power ix equal to cos x plus I sin x, right? Then sin x will be imaginary part of e power ix is sin x. Similarly, what we'll do it here is here we'll add it as imaginary part of e power in by 2 power n, right? Let's check the value. This can be written as like next step it will be I equal to imaginary part of summation n belongs to n e power I by 2 whole power n, right? As you can see here, if you expand these terms, right? If you expand these terms, e power I by 2. Let's first, before expanding, let's see this I power I by 2. This will be e power I by 2 will be less than 1, right? Mod e power I is 1, mod by 2 is 0.5, which is less than 1. Right? Then we can use infinity summation formula. So this part, let's check this part. Summation n belongs to n e power I n by 2 power n. Right? Let's solve this. N equal to 1, it will be e power I by 2. If it's 2, e power 2I by 2 square. If it's 3, e power 3I by 2 cube plus and so on. As you can see it here, R is e power 2I by 2 square by e power I by 2. This 2 will get cancelled. E power 2I by is e power I. This 2 is remain there. Right? The first term is then this summation formula is this summation n belongs to n e power in by 2 power n. Right? A by 1 minus r, right? If the summation is in summation a by 1 minus r. This might have remembered this infinity. Okay, here the first term is e power I by 2 by 1 minus r is e power I by 2. Then it will be e power I by 2 by 2 minus e power I by 2. These two will get cancelled. That means summation n belongs to n e power in by 2 power n is e power I by 2 minus e power I. Right? That implies I is imaginary part of e power I by 2 minus e power I. Point. Then we'll solve it. I equal to imaginary part of e power I. There is a denominator 2 minus e power I. Right? How will you write the conjugate for this denominator part? It will be 2 minus of e power minus I. Right? The upper part will be 2 minus e power minus I. Right? We are multiplying and dividing with the same number to make the denominator looks more comfortable, right? Then it will be I equal to imaginary of this will be e power I into I 2 power I minus it will be 1, e power 0 will be 1, right? Yeah. Then this will be 5 minus 2 into e power I plus e power minus I. That is I equal to imaginary part of this will be 2 e power I is E power I theta is cos theta plus sin theta, right? I sin theta. Here the theta value is 1. Then it will be 2 into cos of 1 plus 2 in I into sin of 1 minus 1, right? By, look at this. I mean, in the denominator it is 5 minus 2 into e power I plus e power minus 5, right? This will looks in the form of e power cos x formula. You might have remembered this cos x formula equal to e power ix plus e power minus ix by 2, right? Here x value is 1. So then this will get 5 minus 2 into 2 cos 1, cos of 1, right? Yes, which is I equal to imaginary part of uh, let's make it 2 cos 1 2i sin of 1 minus 1 by 5 minus 4 cos 1. Imaginary part is this part, right? 2 sin 1 by 2 sin of 1 by 5 minus 4 cos of 1. That is summation n belongs to n sin n by 2 power n equal to 2 sin of 1 by 5 minus 4 cos of 1.